These all MCQs are from chapter radioactivity, and first question is a radioactive source, radioactive nucleus emits either an alpha or a beta particle. What are the products of these two types of radioactive emission? So basically, there is a radioactive nucleus and it may either emit alpha or beta. दोनों possibilities है, alpha भी emit हो सकते हैं, beta भी. So they are asking about the product. What are the product of these two types of radioactive emission?
A different element?
Yes, because if you remember the equation, so in equation of alpha and beta, we are getting different element, right? But in gamma, element will be same because there will be no change in the proton number and neutron number. So in gamma, element will be same. But if we talk about alpha and beta, so elements will be different. So option A will be the right one. Okay, question number 2.
Sir, will we find the half-life like the half of 60?
Half-life of not 60, basically number of emissions per second is given. So at time t is equals to 0, we have number of emission 800 per second, right? So initially we are emitting 800 per second, right?
Yes.
So we have to find out the half value of 800. So what will be the half value of 800?
Oh, 400?
400. You just need to select the half because whole values will confuse you that time and the number of emissions per second are different. So it may be very confusing to find out the value, but the concept is same that you just need to find out that at which time this quantity is going to be half. So at time 20 minutes, we are getting the half of original value. So that is 400 at 20 minutes. So B is the right one. Okay.
Okay.
Question number 3. Now we have graphical representation, but the concept is again same that we have to find out the half-life activity after 8 days. So you may take the reference from the graph that at 2 days, at 2 seconds, at after 2 days, we are getting the value half, right? That is 2000. So after 2 days, we are getting half value, that is 2000. Then after 2 days, we are getting again half value, that is 1000, right? Initially, we start from 4000. So 4000 will be reduced to half. Then this 2000 will reduce to half. Then what will be the next activity?
500?
500. So where will be the 500? Okay, if we are not marking on the graph, we can do it by writing it. So we have to find out activity after half days. So over here we have 4, 6, and 8, right? So after 6 days, we are getting value 500. And after 8 days, we are getting value
250.
250. So it means option C is the right answer, right?
Yes.
Okay. Question number 4 is basically related to handle the radioactive material carefully. So first of all, which safety precaution does not reduce the risk to people using a radioactive material? So basically, this is related to the safety precaution. So first of all, if we start from option A, so keeping the material a long distance from people, so it is safe, right? and keeping the material at low temperature. So remember when we are writing the definition for radioactivity, so in a start we write that spontaneous emission. So in spontaneous means no external effect of temperature and pressure, right? So it means that
Yeah.
if you kept your radioactive material at low temperature, so it will not reduce the risk to the people, right?
Yes.
And other all factors are the genuine factors to decrease or reduce the risk for people using a radioactive material, right? And question number 5,
Will be multiplied by 8?
multiplied by 8. So
No,
actually,
no.
we have a sample and initial rate of emission of 128 counts per minute, right? So we are getting 128 counts per minute and a half-life of 4 days. It means we have to reduce the value of 128 by half in 4 days, right? So we need to find out that how long will it take for the rate of emission to fall at or to fall 32 counts per minute. So what we have to do, process is simple. Whenever they ask the question about half-life, so you just need to start reducing the values into half. So starting from 128, if you first reduce, or we can say that the first half-life of 128 will be after 4 days. And what will be the value? If we
A
reduce
64.
64. So it means if we write first half-life, the first half-life will be like this.
It's 128, 64, and 32.
Okay, so first half-life will be equal to 64. Then second half-life is equals to 30.
32.
So it means after second half-life or after two activity, we are getting value 32 counts per minute, right? Starting from
Yes.
28 and now we are getting value 32 counts per minute. So it means that half-life is equals to 4 days. So it means we take 4 days to reduce it to 64. Then again we require 4 days to reduce that 64 counts to 32 counts, right? So total we are getting 8 days.
Sir, I didn't understand the 4 days part.
Okay. So let's suppose if we start from 128. So initially we start from 128 and after 4 days, half-life means that after 4 days it will reduce to the half of original value, right?
Oh, okay, okay.
So after 4 days, we are getting value 64. Then again after half day, sorry, after 4 days, we are again getting the half value that is equal to 32, right? So it means we totally take 8 days to reduce 128 counts per minute to 32 counts per minute, right? So 8 days,
Yes, sir.
the right answer. So concept will be clear that start reducing the value to the desired value or to the given value in the question and then count the number of days, right? So that will be very easy for you to find out the actual answer, right?
Yes.
Okay, moving towards the next question. Question number 6. So again, they are asking about the precaution. A scientist carries out an experiment using a sealed source with which emits beta particles. The range of the beta particle in the air is about 30 centimeter. So which precaution is the most effective to protect the scientists from the radiation?
A.
A. Handling the source with long tongs, because as far as you kept that radioactive source, so that will be more safe for you. Because temperature will not affect, opening all windows will not save scientists, it will just save the atmosphere or surrounding. Washing in his hands before leaving the laboratory, so that is after precaution, after the process precaution. So handling the source with long tongue is the best option, right?
Yes.
Question number 7.
A.
Yes, very good. A. Okay, question number 8. So question number 8 is also very simple. If you remember the properties of penetration power, in this diagram we are working with the penetration power. So which particle or which radioactive element has the greatest penetration power? Alpha, beta, or gamma?
Gamma.
Gamma. So basically Z is the gamma ray, Y is the alpha, and X is the beta, right?
Yes. B.
So that is B. Okay. So questions are not very typical, right? They are basically depending upon the properties of alpha, beta, gamma, and the half-life and safety precautions. So this chapter is not very much difficult because we have straightforward questions to the concepts, right?
Yes.
Okay, so question number 9.
C.
Mm, C. Okay, so we have 400 and half-life is 5 days. What mass of this isotopes remain? Yes, that is for 400 to 200, that is 100 after 10 days. Good. Question number 10.
C.
C. Which row gives the property of radiation? Most penetrating, gamma, most high. Yes, C is the right answer. Good. 11. Okay, so in this question, basically they initially we have 8 counts per second, right? So when we are talking about the radioactivity in our last class, so in that class we discuss about the background radiation. Background radiation is the normal, or you may say that those radiations are already in our atmosphere, right? Because we have sun radiations, electromagnetic radiations in our surrounding. So all those radiations are already present in our atmosphere, right? So whenever you start the detector or whenever you start the device that detects radioactivity, so that will show you some amount or some counts per second, because already we have our background radiation. So those natural or already present radiations in our atmospheres are known as background radiations, right?
Yes, sir. B.
B. You just need to subtract the background radiation. So particle have only 192 counts per second. Okay, question number 12 is also very easy.
C.
C. It is more highly ionizing than gamma, yes. And question number 13 is so again related to half-life. So initially we have 1600 counts, and after 32 hours, counts fall into 100 counts. Both counts have been corrected for background radiation. It means background radiations are already corrected. We don't need to subtract the values because values are not mentioned in the MCQ. So don't need to worry about the background radiations. So in starting from 1600, again the same process. Start reducing the original value to the given value. If we start from 1600, so let's suppose after first half-life, we are getting value 800, right?
Yes.
And then 400, second half-life, third half-life
200.
200, and fourth half-life 100. So we are getting 100 after fourth half-life, right?
Yes.
So now after 32 hours, so it will take 32 hours for four half-lives, right? So it means what will be the half-life for one activity? You just need to divide,
8.
yes, 8, because we just need to divide 32 by 4, right?
Yes.
Because we have total 4 activities, so that will be equal to 8 hours. So C is the right answer. Good. Okay, question 14.
A.
14A, very which row shows, okay, so you just need to select from the columns. There is some misprinting that is related to penetrating ability of beta particle and the nature of beta particle.
A.
A. Okay, 16.
It's
Oh,
between 2 hours and 3 hours. C.
yes, because we are getting values 250 and 250 is not in the table. It means it will be somewhere in over here. Okay. 17.
Is it because there are background radiations present?
Okay, in 17, a student evaluates how the radiation from a radioactive source changes with time. So the experiment is repeated by many other students who also measures the count rate every 2 minutes. So the half-life of the source is known to be exactly 2 minutes. Why is the measure count always greater than the half the previous value? Yes, because there is a background radiations present over there. Because we are continuously performing the experiment, so that's why we are getting background radiation. 18.
B.
Yes. C. 19.
Sir, I don't know.
Okay, a radioactive substance has a half-life of 2 weeks. At the beginning of an investigation, a sample of the substance emits 3000 beta particles per minute. So, how many beta particles will it emit per minute after 6 weeks? Okay, so basically it's emitting 3000 beta per minute. Okay, and how many beta particles will it emit per minute after 6 weeks? And a radioactive, okay, in this question it is mentioned that we have a half-life over here, 2 weeks, right? So
Yes.
starting from 3000, so starting from 3000, we are getting first half-life equals to 1500, right?
Yes.
So it means it will take 2 weeks, right? This half-life will take 2 weeks. Then again, we will continue to reduce the value to half. Then we are getting our second activity. So value will be
750.
750. And what will be the time? 4 weeks.
4 weeks.
Yes. Then after our third activity, we are getting our desired value, that is 6 weeks, right?
Yes. 375.
375. So it means we are getting count per minute. Yes, we are getting counts per minute 375 after 6 weeks, right?
Yes.
So B is the right answer. Okay. Actually,
Okay.
this question we are getting confused in 3000 beta particles per minute, right? So this will be very confusing that values in minutes and we have to calculate after 6 weeks. But in the start of the question, they already mentioned half-life of 2 weeks, right? Otherwise, question is simple. Question number 20. Again, we have to find out the half-life. So that is also simple.
It's 180 seconds.
Yes, 180 seconds. That is C. Great. Okay, now 21 is related to safety precaution. Which material is best for lining the box to prevent the escape of most radioactive emission?
Lead.
Yes, lead. Okay, compared with beta and gamma, alpha particles, beta and gamma, alpha particles are, so we need to compare beta, we need to compare with beta and gamma, and we are talking about alpha particles.
Oh, B.
Yes, have the greatest ionizing effect. Okay, in cathode ray tube basically we are talking about CRO, cathode ray tube. In cathode ray tube, it releases, it already mentioned a hot tungsten cathode releases particle by thermionic emission. It means we just heat up that metal wire or that metal plate, so electrons will start emitting from that surface, right? So those particles
Okay.
which are emitting from the surface are electrons, right? This is also included in another chapter of CRO, which is very basic. So when we talk about that one or that concept, so there we will also discuss this concept. Otherwise, it is very basic concept. Electrons are emitting from the metal surface when it is electrically heated, right? Okay, 24 is again easy. So we have thick aluminum sheet and the radiation detector shows a reading greater than the background radiation. It means we are receiving the radiation from radioactive source. So which type of radiation is
B.
B? We have thick aluminum sheet in the middle. So if we are
Oh,
working,
gamma.
yes, gamma, because beta radiation will be stopped by thick aluminum sheet. Okay, 25 is also simple. We have to find out the half-life. Half-life of 800 will be equal to 400, right?
Yes, it's B.
B, between 2 and 3 hours. 26 is repeated, right?
Yes,
Okay, 27 is half-life is 10 minutes of a substance. A sample of radioactive substance contains 2000 nuclei. How many radioactive nuclei were in the sample half an hour earlier?
B.
4000.
Yes,
Okay. So half-life of a substance is 10 minutes and a sample of radioactive substance contains 2000 nuclei. How many radioactive nuclei were in the sample half an hour earlier? So half an hour means 30 minutes, right? So 30
oh,
minutes means three half time or three activities, right? So we need to go in the reverse order, right?
yes.
So starting from 2000, now we have to move in reverse order. We have to increase it by,
4000?
yes, we are getting 4000 and this will take 10 minutes, right?
Yes.
Again, we move in reverse order, that will be 8000. It will take more 10 minutes, so total 20 minutes. And again, one more step that will be equal to 16,000. It will take more 10 minutes, so total 30 minutes the time, and we are getting original value of 16,000, right?
Okay.
Okay, question number 28.
Electrons?
Yes, electrons. Okay, 29. A radon detector is placed close to a source of beta particle. Aluminium sheets of increasing thickness are placed between the source and the detector. So eventually a sheet which is 2 centimeter thick is used. The reading on the detector decreases but does not fall to zero. Why does the reading not fall to zero?
Because of C?
There is always some background radiations. Yes. Okay, so the graph shows how the count rate on a detector due to a radioactive source changes with time. What is the count rate after 5 hours? So you just need to reduce it till 5 hours.
It will be C?
Okay, C is the right one. 150 counts per minute. Okay. Okay, so these are some MCQs question of chapter radioactivity. So you may join again, then we will continue with some detailed question, right? Because
Okay,
now
sir.
all the remaining question because most of them are this on the same pattern, right?
Okay.
Okay.